February 23, 1945, the volcanic slopes of Iwo Jima. Private First Class Richard Chambers of the 1st Battalion, 21st Marines crouched behind a shattered tree stump, watching an American flamethrower operator advance toward a Japanese pillbox 30 yards ahead. The Marine carried 70 pounds of fuel and compressed gas on his back, moving with deliberate slowness across terrain littered with volcanic ash and the debris of 3 days of brutal combat. Chambers had seen flamethrowers before on Guadalcanal and Guam, but he had never watched one used at this range against this kind of fortification. The operator, a corporal from Mississippi whose name Chambers never learned, stopped 25 yards from the concrete bunker. Japanese machine gun fire had been pouring from that position for 2 hours, pinning down the entire platoon. Artillery had failed to dislodge them. Grenades rolled harmlessly off the reinforced concrete. Now it came down to fire. The corporal opened the regulator valve, squeezed the rear trigger, pulled the front igniter. A stream of jellied gasoline erupted from the nozzle, transformed mid-flight into a rolling ball of flame that arced through the air and poured through the firing slit of the pillbox. For 7 seconds, the operator held the trigger. 7 seconds of continuous flame. Then the screaming began, and just as suddenly stopped, the machine gun fell silent. The corporal turned and walked back to American lines to reload. What Chambers witnessed that morning represented more than tactical superiority. It symbolized an industrial and technological gap that Japanese forces had been discovering throughout the Pacific War. American flamethrowers, particularly the M2 model introduced in 1943, combined with napalm thickening agents, had created a weapon system that Japanese defenders could not match and increasingly feared more than any other infantry arm. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The development of effective portable flamethrowers had consumed American military engineers since early 1942. The initial M1 flamethrower proved woefully inadequate. Private James Thatcher of the 2nd Marine Division, who received one of the first M1s shipped to Guadalcanal in January 1943, recorded his assessment in a letter home that somehow passed through military sensors. "The thing barely works. The ignition fails half the time. When it does light, the flame shoots maybe 15 yards before burning out completely. You have to get so close to a Japanese position that they can practically touch you." Several men have been killed trying to use these contraptions. The M1's problems were systemic. Its ignition system relied on hydrogen being ignited by a battery-powered spark plug. In the humid, muddy conditions of Pacific combat, batteries corroded rapidly. Connections failed. Operators resorted to desperate improvisation, lighting the fuel stream with burning paper, cigarette lighters, anything that produced flame. The weapon weighed 68 pounds fully loaded, but held only 5 gallons of fuel, providing a mere 8 to 10 seconds of firing time. Most critically, its range of 15 to 20 yards forced operators into suicidal proximity to enemy positions. The United States Army Chemical Warfare Service, responsible for flamethrower development, recognized these deficiencies through brutal combat feedback. In late 1942, chemists at Edgewood Arsenal in Maryland developed a revolutionary compound. A metallic soap mixed with gasoline created a thickened, sticky fuel that burned slower and adhered to whatever it touched. This mixture, dubbed napalm from its chemical components naphthenic and palmitic acids, transformed flamethrower effectiveness. The improved M1A1 flamethrower, modified to use napalm, achieved ranges of 40 to 50 yards. But reliability problems persisted. The ignition system remained unchanged from the problematic M1 design. The Chemical Warfare Service initiated a complete redesign, resulting in the M2-2 flamethrower that entered service in summer 1944. The M2-2 represented systematic improvement across every dimension. Weight remained substantial at approximately 68 pounds fully loaded, but the weapon now carried 2 fuel tanks holding a total of 4 gallons of napalm-thickened gasoline, plus a separate tank containing compressed nitrogen for propulsion. The critical advance came in the ignition system. Instead of temperamental electrical components, the M2-2 used an igniter cartridge, similar to a blank rifle round, that reliably produced flame regardless of environmental conditions. Technical specifications revealed American industrial sophistication. The fuel tanks, manufactured from heavy-gauge steel with precise welds, could withstand combat conditions while maintaining pressure integrity. The nitrogen propulsion system operated at 380 pounds per square inch, providing consistent fuel delivery. The wand assembly, connected to the backpack by a flexible hose, featured two triggers. The rear trigger released fuel. The front trigger fired the igniter cartridge, creating the flame that ignited the fuel stream as it emerged from the nozzle. The effective range of the M12-2, using napalm-thickened fuel, reached between 20 and 40 meters. Maximum range approached 45 meters under optimal conditions. Duration of continuous fire lasted approximately 7 seconds for the full fuel load, though operators learned to use short, controlled bursts to extend operational time. Each burst consumed approximately 1/2 gallon of fuel per second. Production statistics demonstrated American industrial capacity. Springfield Armory, along with contractors including General Motors and Standard Oil, manufactured M2-2 flamethrowers at rates exceeding 5,000 units monthly by mid-1944. Total wartime production reached approximately 24,000 complete systems. Unit cost approximated $200, expensive for a specialized weapon but acceptable given its tactical value. By comparison, Japanese flamethrower development had followed a different trajectory. The Type 93 flamethrower, entering service in 1933, represented adequate pre-war engineering based on European designs observed during World War I. Japanese military planners, anticipating the assault of Soviet fortifications along the Manchurian border, had prioritized flamethrower production between 1937 and 1940. The Type 93 consisted of 3 cylindrical tanks, each 15 centimeters in diameter and 38 centimeters long. 2 outer tanks held fuel, a mixture of gasoline and tar totaling 12.3 liters. The central tank contained pressurized nitrogen for propulsion. The complete system weighed approximately 26 kilograms fully loaded, notably lighter than American equivalents. Fuel ignition utilized a revolver mechanism in the flame gun, holding 10 blank cartridges. When the operator opened the fuel valve by rotating the firing handle, a cartridge fired automatically, igniting the fuel stream. The system provided 10 to 12 seconds of continuous discharge, with a maximum range officially stated as 22 to 27 meters. On paper, Japanese flamethrowers appeared comparable to American weapons. The Type 93 weighed less, carried similar fuel capacity, and achieved similar maximum ranges. Reality proved more complex. The Type 93's reliability issues emerged rapidly in combat conditions. Its ignition system, while ingenious, proved sensitive to dirt, moisture, and the shock of combat movement. The fuel mixture of gasoline and tar lacked the adhesive properties and enhanced burning characteristics of napalm. Most critically, production capacity differed dramatically. Japanese arsenals at Nagoya and Tokyo manufactured Type 93 and the improved Type 100 variant at modest rates. Peak monthly production likely never exceeded several hundred units. Total wartime production remains uncertain due to destroyed records, but estimates suggest between 4,000 and 8,000 complete systems across both models. By comparison, American monthly production alone often exceeded Japanese annual output. The Type 100 flamethrower, introduced in 1940, addressed some Type 93 deficiencies. The flame gun was shortened from 48 inches to 36 inches for improved maneuverability. The nozzle tip became removable for easier maintenance. The operating pressure was reduced from 350 pounds per square inch to 250, improving reliability while slightly reducing range. Otherwise, the Type 100 remained essentially identical to the Type 93. Japanese flamethrower doctrine emphasized assault of fortified positions and, peculiarly, anti-tank operations. Against the lightly armored tanks encountered in China during the Second Sino-Japanese War, flamethrowers occasionally achieved success by directing flames at vision slits and engine compartments. Against American Sherman tanks in the Pacific, this tactic proved suicidal. Distribution patterns revealed strategic priorities. Japanese engineering regiments within each infantry division received between 6 and 20 flamethrowers, operated by designated flamethrower companies. These specialist units trained extensively in assault tactics, But as the Pacific War progressed and Japanese forces shifted to defensive operations, flamethrower utility declined. The weapons had been designed for offensive warfare against static fortifications. Defensive tactics emphasized concealment, ambush, and forcing attackers into close quarters where conventional weapons sufficed. American forces first encountered Japanese flamethrowers during combat operations in New Guinea and the Philippines. Intelligence reports noted their existence but expressed limited concern. A captured Type 93, examined by ordnance specialists at Aberdeen Proving Ground in August 1944, received this assessment. Japanese flamethrower demonstrates adequate engineering for its design specifications, range and fuel capacity comparable to early American models. Significant deficiency in fuel composition. Gasoline-tar mixture burns rapidly with limited adhesion. Ignition system clever but mechanically complex and vulnerable to malfunction. Overall assessment: functional but inferior to current American portable flamethrowers equipped with napalm. The true technological gap emerged not in specifications but in tactical application. American forces, building on experience from multiple Pacific campaigns, developed comprehensive doctrine for flamethrower employment. The Marine Corps, recognizing the weapon's value against Japanese defensive tactics, dramatically increased allocation. Early war. Marine divisions deployed 24 flamethrowers, all organic to the Divisional Engineer Battalion. By 1944, F-Series Marine divisions carried 243 flamethrowers, distributed throughout the entire division. Each Marine regiment received 81 flamethrowers. This distribution philosophy reflected doctrinal sophistication. Rather than concentrating flamethrowers in specialist units, Marines integrated them into standard rifle companies and platoons. The tactical innovation called corkscrew and blowtorch combined flamethrowers with demolition charges and Browning automatic rifle suppression. BAR gunners provided covering fire, while flamethrower operators approached to effective range. The flamethrower eliminated defenders. Demolition men followed up with explosive charges to seal cave entrances or destroy pillboxes permanently. Training standards elevated flamethrower operations from desperate expedient to refined tactical skill. Marine Corps training emphasized movement under fire, range estimation, fuel conservation through controlled bursts, and immediate action drills for weapon malfunctions. Operators learned to work in teams, with an assistant managing fuel flow while the primary operator engaged targets. Quick disconnect buckles on the backpack straps allowed rapid egress if the fuel tanks were damaged. The psychological dimension proved equally significant. Japanese defenders learned to fear American flamethrowers through direct experience. Private First Class Eugene Sledge, author of the memoir With the Old Breed at Peleliu and Okinawa, observed flamethrower effects repeatedly. The job of flamethrower gunner was probably the least desirable of any open to a Marine infantryman. Carrying tanks with about 70 pounds of flammable jellied gasoline through enemy fire over rugged terrain in hot weather to squirt flames into the mouth of a cave or pillbox was an assignment that few survived, but all carried out with magnificent courage. The courage Sledge described was necessary because flamethrower operators became priority targets. Japanese defenders recognized the threat instantly. Machine gunners, snipers, and riflemen concentrated fire on the distinctive silhouette of a Marine carrying flamethrower tanks. The average combat lifespan of a flamethrower operator in intense fighting measured in minutes, not hours. Yet volunteers never ceased. The weapon's effectiveness against Japanese fortifications meant that flamethrower operators often determined whether an assault succeeded or devolved into prolonged, costly attrition. Japanese tactical responses evolved throughout the war. Early encounters saw defenders attempting to fight flamethrower teams with rifle and machine gun fire. This proved ineffective if American suppression fire kept defenders pinned. Japanese troops learned to time their fire, waiting until the flamethrower operator committed to his attack before engaging. Some defenders attempted to target the fuel tanks directly, hoping to cause catastrophic detonation. This rarely succeeded. The nitrogen propellant was not explosive, and the fuel tanks, while pressurized, were designed with rupture discs that vented safely if damaged. More sophisticated Japanese defensive measures involved construction techniques. Pillboxes and bunkers incorporated multiple firing ports with baffles that prevented flamethrower streams from reaching interior positions. Cave systems included sharp turns and multiple chambers, limiting flame penetration. Tunnel complexes provided alternate exits, allowing defenders to evacuate positions under flame attack and then reoccupy them after American forces moved on. These countermeasures achieved limited success. The fundamental problem remained. Once American flamethrower operators reached effective range, Japanese defenders in enclosed positions faced inescapable death. The napalm-thickened flames adhered to concrete, flowed through firing slits, poured into ventilation openings, and consumed oxygen throughout enclosed spaces. Defenders faced three lethal mechanisms simultaneously: direct burns, oxygen depletion, and carbon monoxide poisoning. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Combat reports from major Pacific battles documented flamethrower effectiveness with clinical precision. At Peleliu in September 1944, the 1st Marine Division employed flamethrowers extensively against Japanese cave systems in the Umabrogel Mountains. After-action reports noted, portable flamethrowers proved essential for reducing enemy cave positions. Direct assault by conventional infantry weapons achieved minimal results. Flamethrower attacks consistently neutralized positions within minutes. Total of 117 flamethrower assaults conducted during Peleliu operation, with success rate exceeding 90%. The Battle of Iwo Jima in February 1945 represented the apex of American PROCA flamethrower operations. Japanese forces under Lieutenant General Tadamichi Kuribayashi had spent 8 months transforming the 8-square-mile island into the most heavily fortified position in the Pacific. 11 miles of tunnels connected pillboxes, bunkers, and artillery positions. Concrete fortifications featured walls up to 3 feet thick, with multiple compartments and interconnecting passages. Pre-invasion naval bombardment and aerial bombing proved almost completely ineffective against these positions. Marine assault forces landing on February 19th encountered light initial resistance. Kuribayashi's plan called for allowing American forces to land, then destroying them through interlocking fire from concealed positions. The Marines advanced inland, then Japanese artillery, mortars, and machine guns opened fire from positions hidden throughout the island. Casualties mounted rapidly. Standard infantry weapons achieved negligible results against the Japanese fortifications. Artillery barrages caused minimal damage to reinforced concrete positions. Tank guns firing directly at pillbox apertures sometimes succeeded, but often failed to penetrate or caused only superficial damage. The Marines required a weapon that could reach into the fortifications and kill the defenders inside. Flamethrowers became the essential tool. Corporal Herschel, Woody Williams, of the 21st Marines, 3rd Marine Division, exemplified flamethrower operations at Iwo Jima. On February 23rd, while Marine flags were being raised on Mount Suribachi, Williams's battalion attempted to advance across the island's central airfield. Japanese pillboxes halted the advance, inflicting heavy casualties. Williams volunteered to assault the positions. Williams' citation described what followed. Covered by 4 riflemen, he fought desperately for 4 hours under terrific enemy small arms fire and repeatedly returned to his own lines to prepare demolition charges and obtain serviced flamethrowers, struggling back, frequently to the rear of hostile emplacements, to wipe out one position after another. Williams approached Japanese pillboxes from multiple angles, often crawling to within 20 to 25 yards before firing. He recalled one engagement where machine gun bullets ricocheted off his flamethrower tanks. At another position, he noticed smoke escaping from a ventilation hole, crawled to the top of the pillbox, inserted the nozzle into the vent, and fired directly into the interior. The 4 Marines assigned to cover Williams were killed during the assault. His demolition assistant was knocked unconscious by a bullet strike to his helmet. Williams continued alone, moving between American lines to reload and returning to the Japanese positions. When Japanese soldiers charged him with bayonets, he burned them at point-blank range. By the end of 4 hours, Williams had neutralized 7 pillboxes, enabling the Marine advance to resume. Williams received the Medal of Honor for this action. But his experience was not unique at Iwo Jima. Dozens of flamethrower operators conducted similar assaults across the island throughout 36 days of combat. Captain Frank Caldwell, a company commander with the 26th Marines, provided this assessment in his after-action report. In my view, it was the flame tank more than any other supporting arm that won this battle. The flame tanks Caldwell referenced represented another dimension of American flamethrower technology. In addition to man-portable M2-2 systems, the Marine Corps deployed mechanized flamethrowers mounted on M4A3 Sherman tanks. These Zippo tanks, officially designated M4A3R5, carried approximately 300 gallons of napalm and could project flames to ranges exceeding 150 yards through a modified 75mm gun tube. 8 flame tanks landed at Iwo Jima on the first day. Their effectiveness exceeded all expectations. Marines quickly learned to wait for flame tank support before assaulting particularly difficult positions. The Japanese attempted everything to stop these tanks, including suicide attacks. But the combination of armor protection, long-range flame projection, and massive fuel capacity made them devastatingly effective against cave and bunker complexes. A 1st Marine Division history article stated the flame tanks were the one weapon that caused the Japs to leave their caves and rock crevices and run. This psychological impact, forcing defenders to abandon positions they would otherwise fight to the death to hold, proved as valuable as the physical destruction the weapons inflicted. Japanese defenders at Iwo Jima, facing both portable and mechanized American flamethrowers, found their carefully prepared defensive positions rendered untenable. Concrete walls that stopped artillery shells could not prevent napalm from pouring through firing slits. Tunnel systems that provided protection from bombing became death traps when flames consumed interior oxygen. The elaborate fortifications that took months to construct could be neutralized in seconds by a determined flamethrower operator. Japanese forces lacked equivalent weapons. Type 93 and Type 100 flamethrowers existed on Iwo Jima, allocated to engineering units within the garrison. But Japanese doctrine emphasized defensive tactics that provided little opportunity for flamethrower employment. The weapons had been designed for assault operations against fixed fortifications. On Iwo Jima, Japanese forces were the fixed fortifications being assaulted. The industrial disparity extended beyond individual weapons to supporting infrastructure. American forces maintained comprehensive logistical support for flamethrower operations. Specialized service units performed field maintenance, replacing worn components and recharging nitrogen tanks. Fuel supply chains ensured napalm availability throughout operations. Training programs produced replacement operators to compensate for the inevitable casualties. Japanese forces lacked this infrastructure. Captured documents from Iwo Jima revealed severe equipment shortages. Flamethrowers, when available, often lacked fuel or replacement igniters. Operators received minimal training, learning weapon operation through trial and error rather than systematic instruction. No provision existed for field repair or component replacement. The Okinawa campaign, beginning April 1, 1945, demonstrated these patterns at even greater scale. Japanese forces under Lieutenant General Mitsuru Ushijima constructed defensive positions, rivaling Iwo Jima's fortifications. The island's limestone terrain provided natural cave systems that Japanese engineers expanded into elaborate tunnel complexes. Some cave systems extended hundreds of meters with multiple levels and chambers. American forces, now experienced in flamethrower tactics from previous campaigns, integrated portable and mechanized flame weapons into every major assault. The 6th Marine Division alone employed hundreds of flamethrower attacks during the Okinawa operation. Combat reports repeatedly noted variations of this phrase. After a couple of bursts from the flamethrower, no further resistance or activity was encountered from that position. This clinical language concealed brutal reality. Japanese defenders in enclosed positions faced death by incineration, asphyxiation, or carbon monoxide poisoning. American flamethrower operators advanced through intense enemy fire to deliver this fate, suffering casualty rates that made their assignment among the most dangerous in infantry combat. Both sides understood the stakes. Neither had alternatives. Japanese tactical instructions captured on Okinawa revealed defensive adaptations. Units were ordered to conserve pistol ammunition, limiting each officer to 2 magazines. Flamethrower operators, when available, received instructions to target American tanks and assault groups. But these directives reflected desperate circumstances rather than viable tactical solutions. Japanese forces lacked the resources, training, and industrial support necessary to contest American flamethrower superiority effectively. The technological and industrial gap manifested across multiple dimensions, simultaneously. American M2O-2 flamethrowers featured superior ignition reliability, enhanced fuel formulation, consistent manufacturing quality, and extensive logistical support. Japanese Type 93 and Type 100 flamethrowers, while functionally adequate designs, suffered from reliability issues, inferior fuel composition, declining production quality, and minimal support infrastructure. Range comparisons revealed the complexity of this disparity. Maximum range specifications appeared superficially similar. Plus, American M2O-2 systems achieved 40 to 45 meters maximum range. Japanese Type 93 and Type 100 systems achieved 22 to 27 meters. But effective combat range, the distance at which weapons reliably neutralized targets, differed more significantly. American napalm-thickened fuel maintained coherent flame streams to maximum range, delivering concentrated heat that adhered to targets. Japanese gasoline-tar mixture burned rapidly, consuming most fuel energy in flight, resulting in diminished effectiveness at extended ranges. Reliability constituted perhaps the most significant practical difference. American M2O-2 flamethrowers, properly maintained, functioned consistently under diverse combat conditions. Marines reported minimal mechanical failures despite exposure to volcanic ash at Iwo Jima, mud at Peleliu, and coral dust at Okinawa. The igniter cartridge system proved near foolproof, requiring only that operators remember to replace expended cartridges. Japanese Type 93 and Type 100 systems suffered persistent ignition problems. The revolver mechanism that fired blank cartridges to ignite fuel proved sensitive to dirt infiltration. Combat movement jarred components out of alignment. Moisture caused corrosion that prevented proper cartridge seating. Operators frequently encountered situations where fuel flowed but failed to ignite, leaving them exposed and vulnerable while attempting to diagnose malfunctions. The human dimension of this technological gap expressed itself most poignantly in individual accounts. Private First Class Eugene Sledge, whose memoir provided unflinching descriptions of Pacific combat, observed, "Carrying tanks with about 70 pounds of flammable jellied gasoline through enemy fire over rugged terrain in hot weather to squirt flames into the mouth of a cave or pillbox was an assignment that few survived, but all carried out with magnificent courage." Sledge recognized that courage alone could not bridge technological disparities. American flamethrower operators possessed superior weapons backed by comprehensive training, reliable logistics, and replacements when casualties occurred. They still died in appalling numbers. Japanese flamethrower operators, when they existed, faced similar dangers with inferior equipment, minimal support, and no prospect of replacement. The outcome was inevitable. Manufacturing statistics illustrated the industrial foundations of this advantage. By 1945, American contractors produced M2O-2 flamethrowers at rates exceeding 6,000 units monthly. Quality control procedures ensured consistent specifications across multiple manufacturing facilities. Each component underwent dimensional inspection. Fuel tanks received pressure testing. Ignition systems were test-fired before assembly. This systematic approach maintained performance standards despite massive production volumes. Japanese flamethrower production, concentrated at Nagoya and Tokyo arsenals, peaked at several hundred units monthly. As the war progressed, quality declined noticeably. Skilled craftsmen were conscripted for combat units, replaced by less experienced workers. Material shortages forced use of inferior steel alloys. Time pressures reduced inspection rigor. Late-war Type 100 flamethrowers exhibited machining inconsistencies, pressure leaks, and ignition failures that pre-war examples avoided. Cost comparisons revealed efficiency differentials. American M2O-2 production costs approximated $200 per complete system, including fuel tanks, propulsion system, wand assembly, and igniter cartridges. This represented substantial expense for a specialized infantry weapon, but American industrial capacity absorbed the cost easily. Japanese Type 93 and Type 100 production costs remain uncertain due to destroyed records, but likely exceeded American costs on a per-unit basis despite Japan's lower labor costs. The inefficiency of craftsman-based production versus American assembly line methods offset any labor advantages. The fuel technology gap deserves particular emphasis. Napalm represented genuine chemical innovation that transformed flamethrower effectiveness. The metallic soap compounds that thickened gasoline were not secret formulas or exotic materials. The chemistry was straightforward, discovered through systematic research by chemical warfare service scientists. What mattered was the industrial capacity to produce napalm in massive quantities while maintaining consistent quality. American napalm production reached industrial scale by mid-1943. Standard Oil, among other petroleum companies, manufactured napalm powder that forward units mixed with gasoline to create thickened fuel. The mixing process required no sophisticated equipment, just proper ratios and thorough blending. Field manuals provided detailed instructions, ensuring consistent fuel characteristics across the Pacific Theater. Japanese fuel technology never developed equivalent capabilities. The gasoline tar mixture used in Type 93 and Type 100 flamethrowers achieved limited thickening through crude mixing of petroleum distillates with coal tar products. This mixture lacked napalm's adhesive properties and optimal burning characteristics. It flowed less consistently, ignited less reliably, and burned less effectively against hardened targets. The psychological impact of flamethrowers on both American and Japanese forces transcended technical specifications. For American troops, flamethrowers represented a necessary tool for the unique challenges of Pacific combat. Japanese defensive tactics emphasized fortified positions that conventional weapons could not easily neutralize. Flamethrowers provided a solution, albeit one requiring tremendous courage from operators. Marine Corps training emphasized the psychological preparation necessary for flamethrower duty. Instructors did not minimize the dangers. Operators learned they would become priority targets. They understood the weapon's frightening appearance made them instantly recognizable on the battlefield. They knew casualty rates among flamethrower operators exceeded those of standard riflemen, yet volunteers never ceased. The weapon's effectiveness gave assaulting forces a fighting chance against otherwise impregnable positions. For Japanese defenders, American flamethrowers became a source of profound dread. The weapon combined multiple fears: burning to death, suffocation in enclosed spaces, and the helplessness of facing a threat against which concrete fortifications provided no protection. Captured Japanese documents and post-war interviews revealed the psychological toll. A Japanese army report from Guadalcanal, discovered in captured documents, described American flamethrowers with unusual candor. The American fire weapon projects burning liquid of tremendous range and heat. Soldiers caught in enclosed positions have no defense. Concrete walls which stop artillery shells cannot prevent the fire liquid from entering through openings. The psychological effect on troops is severe. Men who would fight to the death against conventional weapons will sometimes abandon positions when facing the fire weapon. This psychological dominance complemented physical effectiveness. Japanese troops learned through experience that no tactical response reliably countered flamethrower attacks. Attempting to shoot the operator before he reached effective range sometimes succeeded, but required exposing oneself to American suppression fire. Waiting inside fortifications until the flamethrower operator committed to his attack meant facing inevitable death if he succeeded in projecting flames into the position. Attempting to evacuate positions under flamethrower attack meant emerging into the open against overwhelming American firepower. The tactical evolution throughout the Pacific War demonstrated mutual adaptation. American forces refined flamethrower employment techniques through experience. Japanese forces developed countermeasures that achieved marginal improvements, but the fundamental imbalance persisted. American industrial capacity, technical innovation, and logistical superiority maintained consistent advantages that Japanese courage and tactical skill could not overcome. By spring 1945, as American forces prepared for the invasion of the Japanese home islands, flamethrower allocation reached unprecedented levels. Planning documents for Operation Downfall, the proposed invasion, called for massive increases in both portable and mechanized flamethrower assets. Intelligence assessments predicted Japanese fortifications on Kyushu and Honshu would exceed anything encountered previously. American planners determined that flamethrowers would be essential for reducing these positions at acceptable cost. The atomic bombings of Hiroshima and Nagasaki in August 1945 rendered Operation Downfall unnecessary. Japan surrendered on August 15th. The invasion never occurred, but the planning documents revealed American commitment to leveraging technological advantages ruthlessly. Flamethrowers, despite their horrifying effects and the appalling casualties among operators, had proven indispensable for Pacific combat. American forces would have employed them on an unprecedented scale during the invasion of Japan. Post-war analysis by both American and Japanese military historians provided perspective on flamethrower technology's role in the Pacific War. American assessments emphasized the weapon's tactical necessity given Japanese defensive tactics. Without flamethrowers, reducing fortified positions would have required prolonged artillery bombardment, direct assault by infantry suffering prohibitive casualties, or bypassing positions that then threatened supply lines and rear areas. Flamethrowers provided a solution that, while costly to operators, reduced overall casualties by enabling rapid position neutralization. Japanese post-war analysis acknowledged American flamethrower superiority candidly. A 1946 report from Kokura Arsenal, written for American occupation authorities, stated, "Examination of American portable flamethrowers reveals superior fuel composition, providing enhanced adhesion and burning characteristics. Ignition system demonstrates reliability exceeding Japanese designs. Manufacturing quality reflects systematic production control beyond Japanese wartime capability. The combination of superior weapon design, effective fuel technology, and comprehensive logistical support created advantages Japanese forces could not counter." This institutional acknowledgement represented more than technical assessment. It reflected the broader realization that had permeated Japanese military thinking by war's end. American industrial civilization possessed and capabilities that traditional Japanese military virtues could not match. Courage, tactical skill, and willingness to die for the emperor proved insufficient against enemies who possessed superior weapons in unlimited quantities, supported by logistics that functioned reliably across vast Pacific distances. The flamethrower disparity symbolized this larger truth. Japanese Type 93 and Type 100 flamethrowers represented adequate pre-war engineering. In conflicts against Chinese forces or in hypothetical battles against Soviet fortifications in Manchuria, they might have performed acceptably. But against American forces equipped with M2O-2 flamethrowers, napalm fuel, comprehensive training, and systematic logistical support, Japanese flamethrower technology proved obsolete. Individual accounts from Japanese survivors provided human perspective on this technological gap. Lieutenant Tadashi Kojo, captured on Okinawa in June 1945, provided extensive testimony to American intelligence officers. His unit, the 62nd Infantry Division, had defended positions in the Shuri Line, Okinawa's primary defensive complex. Kojo described his first encounter with American flamethrowers in clinical detail. "The Americans attacked our position on April 29th. Artillery bombardment lasted 2 hours. We remained in our caves, waiting for the bombardment to cease so we could man fighting positions. When the shells stopped, we heard tanks approaching. We prepared anti-tank weapons. Then we saw the flame tanks. I had never seen such weapons before. The flame shot from the tank like a river of fire, reaching perhaps 100 meters or more. It poured into cave entrances our artillery had failed to collapse. Men inside those caves died instantly. The screaming lasted only seconds." Kojo continued, "After the flame tanks withdrew, their infantry advanced. They had men carrying portable flame weapons on their backs. These men approached our remaining positions. Riflemen protected them, firing continuously to keep our heads down. The flame weapon operators came within 20 or 30 meters, then fired. The flame entered our firing ports. Men caught in the direct flame died immediately. Others in connecting chambers suffocated or died from smoke. I ordered evacuation. We emerged from our position and surrendered. Fighting further was suicide." The testimony revealed tactical sophistication in American flamethrower employment and its psychological impact on Japanese defenders. Kojo, a career officer who had fought in China and Manchuria, acknowledged that conventional weapons could be countered through training and discipline. Flamethrowers eliminated options. Defenders could die in position or surrender. No tactical doctrine addressed this reality. Private Isamu Goto, another Okinawa veteran who survived the war, provided perspective from the enlisted soldier's viewpoint. Goto served with the 24th Infantry Division, defending positions near Naha. His account, recorded in a 1978 interview, expressed the psychological dimension with affecting clarity. "We were told Americans were weak, that they would surrender easily, that their weapons were inferior to ours. Then we faced them in combat. Their artillery never stopped. Their aircraft attacked constantly. Their tanks seemed unlimited. But the weapon I feared most was the fire weapon. When Americans attacked with fire weapons, there was no way to fight back. If you stayed in your position, you burned to death. If you came out, machine guns killed you immediately. We lost entire squads in seconds. The men operating the fire weapons were very brave. We shot at them constantly, but they kept coming. When one fell, another picked up the weapon and continued." Goto's observation about American flamethrower operator courage deserves emphasis. The mutual respect that sometimes developed between combat veterans transcended the war's brutality. Japanese soldiers recognized that Americans carrying flamethrowers advanced into withering fire to deliver death at close range. American soldiers recognized that Japanese defenders fought with determination against overwhelming material superiority. Neither side doubted the other's courage. What differed was the resources each side could bring to bear. The casualty statistics among American flamethrower operators told their own grim story. Precise figures remain elusive due to incomplete records and the chaos of combat, but estimates from various Marine Corps historical analyses suggest that flamethrower operators suffered casualty rates between 40 and 50% during intense combat operations. At Iwo Jima, where flamethrower employment reached unprecedented intensity, some estimates place operator casualties even higher. Corporal Charles Lindbergh, a flamethrower operator with the 4th Marine Division at Iwo Jima, survived the battle despite multiple close calls. In his memoir published in 1992, he described the experience with characteristic Marine Corps understatement. "You knew the odds were against you. Everyone knew. But somebody had to do it. Those caves and pillboxes weren't going to clear themselves. So you volunteered, got trained, checked your equipment, and went out to do the job. You didn't think about the odds while you were doing it. You thought about your buddies depending on you, about the Marines pinned down by that machine gun, about getting close enough to burn out that position so the advance could continue. That's what mattered." Lindbergh's account emphasized that American flamethrower operators understood their tactical role and accepted the risks through a combination of unit cohesion, training, confidence, and the knowledge that their weapons worked reliably when needed. Japanese flamethrower operators, in the rare instances they employed their weapons offensively, lacked these advantages. Their weapons were less reliable, their training more limited, their logistical support minimal, and by 1944, their tactical situation increasingly desperate. The industrial statistics underlying American flamethrower superiority extended beyond the weapons themselves to the entire support infrastructure. Napalm production alone required massive chemical industrial capacity. Standard Oil and other petroleum companies produced thousands of tons of napalm powder monthly by 1944. This material was shipped to forward supply depots throughout the Pacific, where specialized chemical service units mixed it with gasoline in precise ratios to create thickened fuel. The logistics involved were staggering. Each M2-2 flamethrower consumed 4 gallons of napalm-thickened fuel in approximately 7 seconds of continuous operation. A flamethrower operator might reload and attack 3, 4, or 5 times during a single engagement. Multiply this consumption across dozens of operators in a Marine regiment conducting sustained combat operations, and the fuel requirements reached hundreds of gallons daily. American logistics systems met these demands reliably. Supply ships carried napalm powder and gasoline to forward bases. Shore parties unloaded materials under combat conditions. Chemical service units maintained mixing facilities that operated continuously. Distribution networks delivered prepared napalm to frontline units. This entire system functioned with a reliability that Japanese forces could not approach for any class of supplies, much less specialized chemical warfare materials. Japanese logistics, strained beyond capacity by 1944, could barely maintain basic ammunition and food supplies to forward units. Specialized flamethrower fuel, never a high priority, became virtually unobtainable. Bypassed island garrisons exhausted flamethrower fuel early in their isolation. Even units in active combat zones received irregular supplies. Captured Japanese supply. Records from Okinawa revealed that many units possessed Type 93 or Type 100 flamethrowers, but lacked fuel, rendering the weapons useless. The nitrogen propellant required for flamethrower operation presented additional logistical challenges. American forces maintained compressed gas supplies through systematic procedures. Specialized service units possessed equipment for recharging nitrogen tanks in the field. When tanks could not be recharged locally, the supply system provided replacements. Japanese forces lacked equivalent capabilities. Once nitrogen tanks were exhausted, flamethrowers became inert without access to recharging facilities that rarely existed in forward areas. Training disparities compounded these material advantages. American flamethrower training evolved continuously throughout the war, incorporating lessons from each campaign. By 1944, Marine Corps training centers operated specialized flamethrower schools, where operators received weeks of intensive instruction. Training covered weapon operation, maintenance, tactical employment, malfunction clearance, and combat movement. Live fire exercises replicated battlefield conditions as closely as safety permitted. Students learned to estimate ranges accurately, a critical skill given the weapon's limited fuel capacity. They practiced controlled bursts rather than continuous discharge, extending operational duration. They rehearsed immediate action drills for common malfunctions, though the M2-2's reliability meant such drills were rarely needed in combat. Most importantly, they trained in coordination with rifle squads, learning how to approach positions under covering fire and withdraw safely after engaging targets. Japanese flamethrower training, where it existed, proved far more rudimentary. Operator instruction typically occurred at the unit level, taught by soldiers who had received minimal training themselves. No standardized curriculum existed. Live fire training was limited by ammunition and fuel shortages. As the war progressed and Japanese forces shifted entirely to defensive operations, flamethrower training declined further. The weapons had been designed for offensive assault operations that Japanese forces rarely conducted after 1943. The flame tank disparity deserves additional examination. American M4A3R5 flame tanks represented mechanized warfare's application to a specialized role. These vehicles mounted flamethrowers with 300-gallon fuel capacity, achieving ranges exceeding 150 yards. The armor protection provided by the Sherman tank chassis allowed flame tank operators to approach Japanese positions while weathering small arms fire and even some anti-tank weapons. 8 flame tanks participated in the Iwo Jima operation. Their impact exceeded all expectations despite limited numbers. Marines quickly learned to request flame tank support before assaulting particularly difficult positions. The tanks would advance to within 100 yards of a cave or pillbox complex, then unleash streams of flaming napalm that poured into openings and set entire positions ablaze. The psychological effect on Japanese defenders proved devastating, often forcing them to abandon positions they would otherwise defend to the death. Japan possessed no equivalent mechanized flamethrower capability. Some Japanese tanks mounted small flamethrowers for close defense against infantry, but these had minimal range and fuel capacity. The concept of a heavily armored vehicle with a large capacity flamethrower as its primary weapon was absent from Japanese military thinking. Even if the concept had existed, Japanese industrial capacity likely could not have produced such vehicles in meaningful numbers, given the difficulties already experienced manufacturing standard tanks. The statistical comparison of flamethrower production and employment illustrated the broader Pacific War narrative, American industrial might, translating into tactical advantages that Japanese forces could not counter. Total American flamethrower production, both portable and mechanized, exceeded 30,000 complete systems during World War II. Japanese production of all flamethrower types throughout the war likely reached between 4,000 and 8,000 units. This 4-to-1 or greater production advantage existed despite Japan's lower manufacturing costs and more compact logistics. Quality maintenance proved equally disparate. American forces employed systematic maintenance procedures that kept weapons operational despite harsh conditions. Marine Corps technical manuals provided detailed maintenance schedules. Unit armorers performed regular inspections. Replacement parts were available through standard supply channels. When weapons were damaged beyond unit-level repair, they were evacuated to depot-level maintenance facilities where specialized technicians performed rebuilds. Japanese maintenance capabilities declined throughout the war as spare parts became scarce and skilled technicians were killed or transferred. Late-war Japanese flamethrowers often remained inoperable, not from combat damage but from simple maintenance issues that could not be addressed due to lack of replacement components or qualified repair personnel. The legacy of World War II flamethrower technology extended into post-war military development. American forces continued employing flamethrowers in Korea and Vietnam, with evolutionary improvements maintaining the basic M2 design philosophy. The weapon's effectiveness against fortified positions and its psychological impact ensured continued development despite its horrifying nature. Japanese post-war military forces, prohibited from offensive capabilities under the post-war constitution, abandoned flamethrower development entirely. The Japan Self-Defense Forces, established in 1954, never incorporated flamethrowers into their equipment inventory. This decision reflected both constitutional restrictions and institutional memory of flamethrower effectiveness, witnessed from the receiving end during the Pacific War. The technological and industrial gap exemplified by American M1 and Japanese Type 93 flamethrowers represented in microcosm the broader Pacific War narrative. Superior American design, enhanced by chemical innovation in napalm development, backed by massive industrial production capacity, supported by comprehensive logistics, and employed by well-trained operators who understood their tactical role, created advantages that Japanese forces could not match despite courage, determination, and tactical skill. The flamethrower war in the Pacific was decided not on battlefields but in factories, chemical plants, and training facilities, thousands of miles from combat zones. Japanese soldiers defending Iwo Jima, Okinawa, and countless other Pacific islands faced American flamethrower operators backed by an industrial and technological system they could not hope to equal. The outcome, in retrospect, was never in doubt. Material superiority, when sufficiently pronounced and systematically applied, determines military outcomes regardless of individual valor. Private First Class Richard Chambers, who watched the flamethrower attack on Iwo Jima that morning in February 1945, survived the war and returned home to Iowa. In a 1994 interview for an oral history project, he reflected on that moment. "I saw a lot of weapons during the war, rifles, machine guns, mortars, artillery, tanks, but nothing affected me like watching that flamethrower operator walk up to that pillbox and burn it out. The courage it took to carry that weapon into enemy fire, the terrible effectiveness when he pulled those triggers. At that moment, I understood we were going to win this war. We had better weapons, more ammunition, and men willing to use them despite the cost. The Japanese fought bravely, but they couldn't match that combination." Chambers' observation captured the essential truth. The flamethrower gap between American and Japanese forces symbolized the broader material and industrial disparities that determined the Pacific War's outcome. Technical specifications mattered. Napalm chemistry mattered. Manufacturing quality mattered. But what mattered most was the systematic integration of all these advantages into a comprehensive system that reliably delivered overwhelming force to the tactical edge where combat decisions were made. The two flamethrower systems, American M2 and Japanese Type 93, told the Pacific War's story in miniature. One represented the world's most powerful industrial economy, fully mobilized for total war. The other represented a nation with limited industrial capacity, stretched beyond breaking point by continental commitments in China and unrealistic strategic ambitions across the Pacific. When these systems met in combat on volcanic islands and coral atolls, the outcome reflected not the courage of individual soldiers, but the productive capacity of entire nations. In that contest, Japan was overmatched from the beginning. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.